So we haven't done a lot of this, so good job for picking up on it, on how to set up the integral to find an area using a function as our height is really what that is. So, awesome. Any questions on it?
Well, what does the graph have to do with this? Just like showing you a little.
Yeah, the graph doesn't necessarily need to be there at all, but it kind of provides you a visual of what all the words are saying and showing you like, hey, we're talking about this area under the curve.
Being completely honest, I did it like the R of t equals 2t.
Oh,
I just
did you look at the graph? Okay, so there you go. You could do it either way. That's interesting. I would have just looked here, but also the graph is
I don't like
nice.
reading.
Yeah, do you read books? Me,
For fun.
me neither. Not very
Not
often.
my choice. I don't have time to do that anyway.
Yeah, I know how you feel. I wish I read more.
I used to read.
I don't know. There's some books that are like interesting, but then it's like.
Yeah.
I found like one book that I was really interested in, and then I just stopped, and I was like, well.
The only school book that I actually found interesting was To Kill a Mockingbird.
You like that one?
Yeah, that one was actually cool.
Yeah, I remember reading that one. It was pretty good. Okay. What? Okay. So here's what he said. Remember tangents, not tangent. Parallel means what? What's equal? Okay, so same slope. Okay? So, huh?
But if you're setting it, how could you set h prime of x equal to g of x? Because isn't g of x that curve?
Yep. So we
then
need to
like
know
you
the
need
slope
g
of
prime
this line.
x. So h prime of x equals g prime of x? But the slope.
No. So, okay.
We're trying to find the slope of f, and the slope of f is g. Oh, I see, that makes sense.
Okay.
Okay.
Yeah, so f prime of x is the slope, right?
Yes.
Is the slope of f.
Yes.
And that is d dx of, where is it? There it is. Of this guy. Right?
Yes.
Well, remember those cancel, so it ends up just being g of x. So our slope of f is g of x, and it wants at x equals 5. So g of 5 is 2. And then it says we want the slope of h to be parallel, so we want the same slope. So we want h's slope to be 2. So that's this thing has to equal 2. Yeah, and that's why we want it on a calculator.
Oh, right, I can just graph.
Yeah. So we need to look for what x value when h prime equals 2. And this is an x. It kind of looks like a pi, so x over 3. Yeah, so x squared sine x over 3.
So would you just plug in the values into each prime?
Well, so we want h prime to be 2, right? So I suppose you could use either the graph or the table function. I would probably use maybe the table.
I use the graph and just put a line for 2 and then put,
Okay.
and then it tells you where it intersects.
Well,
So we're looking for where the right side in the table equals 2.
yeah.
Does this calculator, like the TIs don't let you ask for a y value, does this one?
Well,
I'm
you
trying
can-
to, but I don't know how.
Yeah, I feel like that was this thing that we could do.
I mean, you can change your how, like, what your X value is going by, like, you can change it to 0.1 and you'll get closer, but you can't specifically ask for yeah, you can change the step size so that.
What if we just go over there and try it? Like type 2, does it let
It
us?
doesn't
No. Okay. Yeah, so I guess probably Christian's idea of in the graph, if we set just a y equals 2
Yeah, that's what I did.
and then find the point of intersection, that's probably the best way.
It just does it.
Yeah, if you go over to that first valve. That was it. Right there.
So 1.8567.
Yeah. That question's a lot easier than I thought.
Yeah.
They just wrote it so.
They just write it so.
They wrote it so
It's like the oil part.
The one on the test, you mean?
Yeah.
What was that the one getting the cleanup job one?
Yeah. it was
Yeah.
like pretty-
Yeah, that's true. That was worded pretty weird too.
It turned out.
I didn't even do any math for this question. We just have to know that.
Plug it in.
Like,
You had to know this, right?
right, and that's more like calculus concepts.
Yep, it is. It's totally concept. It does bug me a little that this line is there.
It bothers me so much because I was like, well, we're trying to find. That's where I was messing up. I was like, don't we have to take g prime of x instead of equal to?
Yeah, which would be finding the slope of that line.
Right.
It's tricky, right? It's frustrating, but we did it. Good job. All right, here's another one kind of like that. It has the calculator icon as well, but I'm gonna make these bigger. There we go. How about the rest of it? Does it look readable?
Yeah.
I need to scoot that down a little. All right, so big idea. F prime is what? Is G. So G of x. So if we say, so we want H of x to equal G of 2, which is 1. So let's try that solver strategy for that one and see.
Yeah, I gave you 1.3, which is what I got from the graph. X squared minus b to the x plus 3. And then click alpha pi, or shift pi.
Oh, thank you, because there's no way I'm reading that.
Oh, sorry.
Equals 1. And solve. Wow, that is pretty dang cool.
That's why.
1.319 is A. Huh?
Texas Instruments is about to go out of business.
I agree. That's pretty awesome.
Understand.
And there's so much stuff here too, like even like the elements and all that stuff. Like,
Yeah.
Yeah, well, I was using it for a chemistry test where we were doing electronic configuration, and it's just on there. I don't have to do any of the periodic tables.
You can just look at it. That's pretty awesome. All right, cool. So how did the homework problems go that were kind of like this?
They were good, yeah, I think.
Right? Did you guys have a chance to check them?
No, I didn't check.
I did not.
All right, let me pull that up so you
That
can.
was just that
There's starting with the first section of odd ones.
Yeah, you just had us do the test prep, right?
No, I said odd ones. Odd ones and the test prep. Are you checking?
yeah, I'm checking.
Can we do number 10?
Yeah.
You know, well, I kind of just do a lot of those.
Okay. Let's do 10 and whatever else. let me know and I can go to the next page.
You're good.
Okay.
What does that say on
13 says 2f of 2x.
Oh, okay.
Yep. Kind of a weird
Like
looking
the
f.
integral symbol.
I know, it does kind of. In fact, later on in calculus, when you start doing like flux integrals, you put, it's like the integral symbol with like circle around it in the middle.
Oh, I think I've seen those.
Yeah.
I remember. We didn't do it with a lot of it. We just like showed it to us.
All right, let me go down. The last couple, we did the last one yesterday, so
Yeah.
that one's B. Yeah. So, any issues with any of those besides 10? Okay, let's do 10.
And we went over 20, right?
That one?
Yeah.
Yep, we did.
3/4
3/4
squared
units.
per second.
Yep, good job. Alright, so we're finding f prime. I'm just going to write the integral symbol here and then t squared dt. Okay. I'll just write all of it. Okay, so remember the derivative cancels the integral,
Yes.
which means that we can plug in, for t we can plug in tangent of x squared, and then we have to do the chain rule on tangent, so then we get secant squared of x, and then tangent of x squared is the same as tangent squared of x. Does that help?
Yeah.
I just did my derivative wrong.
That's okay. Any others? Good on the rest? All right. So let's do 6/5. Hopefully, maybe 6/6 too. We'll see. So this is very much like Unit 5. So tell me what you remember about last unit. What kind of stuff were we doing in that unit?
Minimums, maximums.
All right, finding minimums and maximums, critical points.
Using like first and second
Yeah.
derivatives and stuff.
And then, how did we know if we had a local max specifically?
There's a critical point
I
and
didn't
then
switch
double
it.
point was negative.
If
Yeah.
the critical point if the critical point was a 0, then it does not exist, right?
Yes.
Okay. This, it turns out, will probably be a little easier to use the signs, not a sign chart, but the sign concept. So what sign convention did we use to determine a local max? Or,
Feels like
Positive to negative.
all right, so negative to positive was a minimum, and what was that of? Like negative and positive
prime.
what? F prime. Okay, max was positive to negative. Okay, you guys, when I'm sitting in here working on stuff, I'm doing this sometimes to myself. I'm like, "Grr." That stuff got to me.
You just confused me so bad. You said sign, you said what sign changes? I instantly thought of the graph of like sine.
Oh man, yeah, that would be.
I'm like,
Changes a lot.
It's constantly changing, yeah.
That's not tiring. How about
So yeah, we're gonna do all that stuff, only now we're gonna have integrals in there. But we know what to do with that now, I think. So, accumulation functions, we know are in this form. And I do want to mention, I tend to rewrite the function name as capital F just for my own self. So I don't know if you want to try that. I think if I explain what I mean on those ones we just did, like for example this one, I think it's helpful, instead of calling this F, to put it in the form I'm used to, which is capital F. And then knowing that it's, eventually I'll probably have to switch back, but when I see this, it reads to me as an integral. Capital F does.
I mean, maybe not for that problem specifically, but like they purposely use like F and G and H.
Yeah. So on ones where like if this is G, you'll see it in today's work maybe, but I'm thinking capital F, and it just helps.
Yeah.
Sometimes I write it down that way. There we go. So we know that big F prime is little f, okay? And so it's basically, when we go through all this, it's like a derivative shift, if you want to think of it that way. So you guys were just saying F prime helps us, the sign of F prime tells us where maxes and mins are. The sign of F double prime tells us where concavity is, right? And points of inflection. But because we have this integral on the accumulation function, now our derivative is shifted 1 over, so to speak, right? Like instead of prime, it's just regular, and instead of double prime, it's prime. That's kind of the summation of this whole section. Okay, so let's kind of write.
Wait, can you explain that again?
Yep, we'll do it right here.
Okay.
Okay? So F, big F. Just
Yes.
think of it as some function, right? Not necessarily this one. If I just say when is it increasing, what has to be true?
Like based on what?
F prime
Just
has
this,
to be
like ignore
positive.
everything else, and just, if I say we have some function capital F, and I say, when do we know that it's increasing?
The slope is
F prime is what?
Positive.
Yeah, positive. Okay? And decreasing when F prime is negative.
So is that referring to?
Okay, so that was just, if we ignore all this
Left.
stuff for a second,
Right.
okay? Now, going back to what that means, what is F prime for the, let me move that up. Now, for the accumulation function.
Little f. Little f.
Yeah, so that's just plain F, right?
And it's because, isn't it because F of X has to be a rate? So that's what's.
It is not so much because of that, actually. It is kind of because it's a rate, we're allowed to write it this way, but it's more because taking F prime undoes the integral, and all we're left with is X, or F, excuse me, little f, right? So it's like, to get over here, it's always going to be d dx of the integral, and those cancel, and we're just left with the inside. So f prime is the derivative of an integral, which is just the leftovers inside. Does that make sense now? Okay. So let's continue, and I'll let you fill out that other side. So a relative max, in terms of just general functions, if I say, here you go, how do you find where there's a relative max? Well, that would be when f prime changes sign from what? Positive to negative. Okay, and so these are the kind of justifications for this kind of problem we have to use, like f prime changes sign from positive to negative. Okay, and then of course the minimum is the same, but opposite signs. Okay, how do we know about concavity?
Double prime. Double prime is
So concave up, it's what?
positive.
Yep. I switched from inequality notation to just signs. You can do it either way. In fact, maybe I'll change it just to be a little more official. Okay? And then point of inflection, we have to be a little bit careful on. Yeah, F double prime changes sign. Which happens where? Typically. Not always, but typically.
Where F prime, or where F double prime is 0.
Yeah, or does not exist, right? Mainly, I want you to focus on the fact that it's changing sign. Okay? Don't just look at 0 or does not exist. Okay, why don't you fill out that other side based on what we just filled out?
Probably should go down, it should go up.
It starts to get jumbled after a while. Okay. I guess I should have pointed out this is the graph of f. And so we're looking for f prime, which is what? I should have written that next, actually. So f prime is little f. And we want that to go from negative to positive. So, where do we have a relative minimum?
At 4. Dude, I swear.
So F is F prime.
Yeah,
So negative values to positive values, so right there. So yeah, we can call it like 5 point.
I was thinking of just like a regular graph,
Yeah.
but it's F prime.
What are we deciding? 5.4 or 3?
Oh, I just said 3.
Okay, we'll go 3. All right, relative maximum. So that is positive to negative. Yeah, at 3. Okay. All right, intervals where G is concave up. So what are we looking for there?
Where, so.
What did you say?
Inflection. Well, I guess never mind.
We don't have to find the inflection point to know where it's concave up, but it's using what? It's still using the same derivative, which is f double prime.
So
Big F double prime.
big F double prime, which is F.
Yeah.
So F.
And what does it have to be for it to be concave up?
Positive.
Positive. Okay. So on this graph, what are we looking for?
Where the slope is positive.
Where the slope is increasing. Yeah, positive.
Is it when it's increasing and positive? Actually, wait.
The slope doesn't have to be increasing, just has to be positive.
Well, because isn't this a positive slope? No.
This is a positive slope, yeah.
Right, and that's concave down.
But the slope of this,
Right, but that's
Yes.
S prime of X.
yeah.
Okay.
I thought yesterday was Friday.
Dude.
Oh, man.
I'm like dying today. What?
It's okay. So what interval do we have a, remember this F? The little F that's on it that this graph represents is what?
Big F.
Big F prime. So we're just looking for the slope. This, you could almost mark this as F prime, right? If you wanted to change this to where you're not getting mixed up, do that. Right?
I didn't even see that F.
So now we know that for F, if this is F prime, then we need to look where it is in, like, just a positive slope of it is, how do I say that? Is F double prime is positive at that point. Does that make sense? The slope of the slope graph.
Yeah.
Okay. So that interval looks like 4 to 5.3. No, sorry. 4 to 6, yeah.
See, I thought that was the graph of big F.
Well, that would make it confusing for
Because
sure.
I didn't even see
Yeah.
that to the left.
Okay.
Oh, it's on my paper. Oh my god. Oh my god.
All right, concave down would be what?
F double prime of F is less than 0.
Uh, 2 to 4 looks like. All right, points of inflection. So this is where you have to be careful. You can start where by looking where what?
So that's where big F double prime. Change sign. That means that F prime changes. That means that
So the graph that we're looking at, the slope.
so it's gonna be like a relative extreme of F double of F prime.
Yep. So the graph, this graph that we're given, changes sign. The slope of that graph changes sign. So slope.
Pi of X equals 4.
Yeah. Okay, next, so just looking on the interval of 1 to 5, if G, which is what for us?
F. I just
Big
wrote
F.
F on top.
Good.
There's a maximum G. So how's max?
F3.
Okay, so didn't we already find where it has a max? Oh no, that's a relative. So we need the overall maximum value. Okay, so this one, remember F is the integral. It's the area now, right? So if you think about this on the interval 1 to 5, like here it's positive. Let me draw this in. And there. And then here it's negative. So if we're accumulating left to right, where does it get the biggest it will get before it starts going less? At 3, right? So we just need to figure out our area up to 3. In other words, find this 1 to 3 of F. Okay, so it's just counting these boxes, like 1, 2, roughly 3, right? Like you said. Oh, but hold on.
But F of 1 is 5.
Yeah, we have to add 5 to that.
Oh, yes.
Sorry about that.
We would add 5. Oh, because it.
It's like it starts with 5 kind of idea, right? Now, what bugs me about this problem? the way it's worded, we'll have to, when we get to topic questions from AP, we'll try to compare, but to me, when it says F of 1, or G, in this case of 1 is 5, I read that as this area is 5. Because it's, and maybe I'm reading it wrong because I'm starting at 0 and it doesn't necessarily imply that, but that's how I thought of it.
Yeah.
And then that would make, to me, this would be 5 because it's the same size, and then this would be 2.5. That's how I thought of it. But that's not the intent. And I think it's because it doesn't tell us the limit of integration to get that one, the g of 1 of being 5, maybe. So, I guess just understand that if it gives it that way, just add that to your total. Does that make sense? All right, next page. Huh? So we have this, again, they're using g for the accumulation function. Which we like kind of f. So, and we have this graph. Let's point out for Aiden that it's f. just teasing. All right, find the x value where g has a relative maximum. So now it says relative, not overall. So what are we looking for?
There. Big F prime of X changes signs from positive to negative.
What does it say maximum? It's positive to negative. Did you say that?
Yeah.
Okay.
Now I want this to get a number for. This is not the same problem.
Find the x value. It's not the same problem, but it's the same concept, right? So find the x value where that happens. Huh?
Oh wait.
You said you said it's not the same problem.
Is it not the same problem?
Well, it's the same graph.
It's the same graph, yeah. But I guess I don't know what you mean by same problem as what.
Well, as when you went over here and said,
What's the
find a
next?
relative maximum G.
Yeah. That's right there on A.
But this was different, right?
But that's just the integral function, right?
Zero to x over 2 plus 5.
So that means we have to take F, big F, differentiate it, and then do the thing that we did.
What's the thing that we did?
So the F prime of X would be F of G of X times G prime of X.
Yes, that I see what you're saying. I got what you're saying now. So basically, we know that this is f of x over 2 plus 5 times 1/2. Okay.
Oh, no. Yeah.
We're still finding where it equals 0. Why?
On the critical point.
Okay. So remember this, where does this happen on the graph? Ignore what's in here.
The derivative, wouldn't that go to x over 2 plus 5?
Well, when we do the derivative of this thing, remember the integral cancels and then we plug that in as f.
Oh.
And then we do the chain rule on the piece that's inside. Okay. But then what I'm asking is, this is still a valid statement. For a moment, you need to ignore what's in here and tell me where f of whatever, like where is this equal to 0? Just f.
3 and 5.
3 and 5. Okay?
3.
But we're only looking at 3. Why?
Because it's
Because
from
it's
positive.
similar with those with positive.
Good. So, let me write it over here.
So it was the same part.
Basically, but it just gives us like an actual.
This happens only at x equals 3. Right? Okay, now we have to solve for x by doing what?
Plug x into.
This has to be 3.
Oh.
Right? So x over 2 plus 5 has to equal 3. In other words, if I force this to be 3, f of 3 is 0, the 0 that it goes from positive to negative, okay? Does that make sense now?
Yeah. Yeah. So okay. I mean, like I understand why we would do that. But how does the interval that we're looking at the integral change the value of like the points?
Those aren't.
It doesn't. It doesn't change. If we think back to this now, this is, since it's still the same function graph, what changed is the fact that this is now x over 2, not just in the previous one, it was just x. So whatever value we found for x was the value. Because there was no like messing around with that value. So we're saying the same thing as over here. We said 3 for the relative max, right? But that was just the x value that we got to for that. Because remember when we plugged it in, it was f of x. On this one, it's still 3, but the limit now, instead of just being that 3, it's saying x is not this x value, it's the x that makes the top limit 3. Probably would have been better to do like K or some other letter there, so it doesn't get mixed up with it being an x coordinate.
I just remember like we talked about B being there, like that was
Yeah.
B.
Okay, we
It's
could
like-
we could have made it a B.
And that was like the end interval.
Yeah.
I was like just like thinking like we're just changing the end interval, so it wouldn't change the inside.
Well, we're still dealing with the same function setup. It's just that now instead of this being just a to b, where a is 0, b is some other variable that we're solving for. So we could do it like we did in the first example on the previous page, where we find b is 3 where this occurs, right? B is the location on the x coordinate, on the x-axis, where it changes from positive to negative. But now we just fiddled with what we're calling that and calling it x over 2 plus 5, where we have to solve for that different number that makes that to be 3. So we're not changing any intervals in the function.
Okay.
This isn't a different interval in terms of what's going on with positives and negatives and maxes and mins. It's just complicating the way that we describe that or calculate that number is how I would describe it. Does that help?
Yeah.
But you disagree?
Well, it was just so fundamental. Like it made so much sense that a to b is the interval that we're looking at the integral. And so like now that I'm thinking about it, like even if a changed, then that would change the output of our integral.
True. But right now we're not talking about the area underneath, right?
Right.
We're just talking about
The max.
its derivative.
Right. Well, yeah.
No, keep thinking. I like it.
Yeah. I don't know. It's just like I really like it made so much sense that B to A was what we're looking at on the
Yeah.
so like
We still are.
Right, but now it just changes.
Now b is just like an expression instead for this one.
Right. That's weird.
Yeah, it is weird. I definitely agree with that. But do you feel okay with being able to think of it that way?
Like I said, like the math, like I understand why you did that. It's just like I don't understand why we have to do that.
Yeah, that makes sense. Why do we have to? Honestly, there's probably, I wonder if there's I'd have to try to think pretty hard about it, like an applied reason for changing that to some expression instead of just like another number, like the other limit of our integration. But,
Yeah. It doesn't make sense, because like, I'm thinking like if we're going through a function, taking the integral, and like the end, our b changes based on x is just gonna keep moving, so why would the x value or the y value of our integral change at all? If it already
well, that's kind of what I was saying, like maybe it shouldn't have been x as in x coordinates on the x-axis.
So does that x not have anything to do with the x?
It probably should have been a different variable, like a k or something. Because that's really how we're solving. Because again, like this is still 0 to 3. That doesn't change. Those are the x values, right? On like in terms of x coordinates, right?
Right.
So this is like being used as a different variable.
Oh, because we're using t.
It's being used as a different variable that's embedded within the x coordinates of integration.
So it's basically just telling us that we don't know where we end. It's like telling us we end somewhere where a number divided by 2 plus 5.
That gives us, yeah, like if we could ask it like an area of 5, or in this case a maximum. Yeah, like I think you're thinking of it right now. Yeah. Because I think I know where you're coming. You're trying to say now like our upper limit is -4 or something. Is that kind of what you're saying? Like
Well,
it messed it up?
Like it would like, I don't know, it's just like weird how the x of our relative maximum changed.
Yeah.
Because b changed.
This x is not an x coordinate on the x-axis.
Oh, that's the x.
This is like the value that gives us that x coordinate.
So
Which is why I wish it wasn't an x. Like this, that should have been something else that we're solving for. It's like, you know, in algebra when you're like, I don't know, let me think of an example.
like ax squared plus bx plus c. Like the a.
I'm trying to think of an example of like where you're solving for a variable so you can plug it into another thing that is your main interest, I guess.
Like the k and the h's.
Yeah. Yeah, like there you go. Like think of vertex form. Ax minus h squared plus k. You know, like if this is our coordinate, right? Our x that's referencing the x-axis, but we could solve for k. Like what's that y coordinate of the vertex kind of idea, and treat that as a variable, but it shouldn't be a y because it's not the y-axis necessarily, or whatever. Like I don't know if I'm making sense. That's how this is. Like our relative maximum is not happening at -4.
It's still happening at 3.
It's still happening at x equals 3. It's just to get 3, this random variable has to be a -4 to make it be 3. It's like someone just said, hey, let's complicate that upper limit by sticking in a calculation there. Instead of,
So does it mean the x on the previous problem, like b is 3?
yeah, it does. Because our upper, where did it go? Our upper limit of integration is just whatever we calculate on the graph. It is the same, right?
Oh.
You have 5 compasses.
I don't have any. Oh, compasses. Yeah, but give me a second. Yeah, so it is 3 in that case because there's nothing going on here, right? It's just the upper limit.
So the numbers that we solved down here, are those p's or are those x's?
those are,
Cause like the x-axis is t, right? Like
yeah,
on the graph.
okay. And this is one thing that I have an issue with about how this is introduced. So remember I showed you the other day that the limits of integration for a definite integral, I'll write it how we had it then. F of x equals, and then f of x dx. Shoot, sorry about that. It doesn't have to be t. Okay, can you read that again? This is bigger. Okay, so when we go to do this down the road, we're going to be doing big F of B minus big F of A is how we will calculate that area. So we take the upper limit, plug it in, and then take the lower limit and plug it in, and it's a subtraction thing, okay? So the reason it's giving it like this with f of t dt is because they're choosing to put variables up here.
So the x and g of x isn't the x that's up in the b part.
It only is because we're plugging it in.
Okay.
If I was going to write, how do I say this? If we ignore the limits of integration for this function, it would be this. Don't put limits on there, okay? And then this would be f of t dt. So this would match that. But because we're choosing to put stuff up here that's not t, that's what we're plugging in. So you can kind of see the parallel. We're plugging in b, and that's going to be f of b. And then a would be here. So in this, it is g of x only because we're plugging in x once we take the integral.
So if we, instead of writing x up there, we wrote b,
b, yeah.
would our answer still be x? Because those are x values.
If we wrote b here,
Yeah.
yes. Are you saying would we say at x equals 3?
Yeah.
Yeah, we would. Because these are just constants of integration telling us the bound, right?
We just don't know.
And those are defined by this function and what we're interested in looking at. But think about like if we change this one to x squared plus 5. That's just saying, well, x squared plus 5 has to be 3 for that to be true still, right? And now when we solve this, it's going to be two imaginary numbers, like positive, negative root 2i, right? If we solve that.
Right.
Because we're taking this and plugging it into this to make that 3 to get that upper bound.
Okay.
It could, I think, just as easily be J or some other letter. Or
So
B.
can I just put that just to kind of complicate the situation?
Yeah, yeah. Yep.
It just didn't do that, right?
Yeah.
It's still the same function, it's still being integrated up to 3, and that's the maximum, but it's not, that x is not an x coordinate, but a variable value that makes the x coordinate, the actual x coordinate 3.
Wait, but I'm curious.